In this video, I'm going to show you how to use Desmos to do some of the calculations that we learned about in Module 7 in Section 6.1 and 6.2. In 6.1, we talked about calculating expected value, and we're usually given a table. For example, this is data from your book. It's example 2 in Section 6.1, and my column of X's are the number of free throws made by a basketball player who's making 3 attempts. So they might make all of them 3, or they might make none of them 0, or they might make 1 or 2. And then in the Y values, I have the probability. So the probability they miss all the shots is 0.01. The probability they make all the shots is 0.51, and so forth. So we know that we can calculate expected value by multiplying each of the values times the probability that we achieve that value. So 0 times the probability that we get 0 shots plus 1 times the probability that we get 1 shot, and so forth. And that would be the expected number of points that I would expect a player who has these probabilities to earn if the player were to take 3 shots. So I could, of course, just do 0 times 0.1 plus 1 times 0.1 plus 2 times 0.38 plus 3 times 0.51. And you can see that I would expect that player on average to earn 2.39 points. And another way of thinking about this is if this player had this opportunity 10 times, the opportunity to make 3 free throws, I would expect them to get about 23.9 or 24 points, what I would expect them to score. The shortcut for doing this is if I have all of my data in a table like this, instead of typing it all out here, I can use my Desmos total function, and then I can tell it to calculate each of these multiplications, the X variable times the Y variable, and sum them all up. And that looks like this: total, X. And to get the underscore, I'm typing the underline. So it's that key that is up above the, up and to the right of the P on your keyboard. And it makes either a dash or an underline. I want the underline, so I have to do Shift and then hit that key. That'll give me the X1. And then to do times, I can either use my keyboard here, and I can hit this key. I can also hit the asterisk, which is the Shift-8 key. And then I want Y1, so I'm going to do Y and then hit that underscore and a 1. And you can see it does all of this calculation for me, so I don't have to type this all out, which would be really convenient if I had even more probabilities that I needed to sum. That is your help for expected value. We can also use Desmos to do things like permutations and combinations. And in the formula that we use for calculating probabilities from the binomial distribution, we used the function n choose r, and we have that in here. So it's way down at the bottom. If you click on functions and scroll way down to the bottom, you can see it's right here. We also have permutations, so combinations, permutations. And for the binomial distribution, we use this one. And we can either click that button, or if I remembered that it's NCR, I can also type N capital CR, and then it remembers that for me. And then it wants me to tell it the number of items that I have to choose from and the number of items that I'm choosing. So if I'm calculating 9 choose 3, I put the 9 first, that represents the N, and the 3 second, that represents the R. And it will do that calculation for me. And we have the formula that we can use for calculating those binomial distribution probabilities. And that formula, remember, uses N choose R, or combinations. We can also get Desmos to do the whole thing for us. So we had an example in the book of a binomial distribution, and we had the information that about 25% of households only use wireless phones. So 25% are only using wireless phones. And if we took a sample of 20 households, then we could calculate the probability that we had maybe 5 of those households had only wireless, or 3, or some range of values. So let's see what that looks like. So if the probability is 25% that they're wireless only, and I'm sampling 20, then to do these problems, I'm going to use the binomial distribution. And again, that's in here if I click on functions, and it's a probability distribution, and here it is. And again, if you remember that it's binomial dist, you can just type that out, binomial dist. And so first I'm going to put in the number of trials. So that's the number of households in my sample. And in this case, we said we're sampling 20 households. And then the probability of a success. So if I'm given the information that 25% of households are wireless only, and I'm interested in finding what's the probability that 3 of the 20 or 8 of the 20 are wireless only, then my success for the purposes of this would be being wireless only, and that probability is 0.25. So I always kind of want to frame it in terms of how the questions are answered. I could have called not being only wireless a success, but then I would have had to frame the questions in that way. So it's easier to use the probability of wireless only since I'm interested in what's the probability that a certain number of households are wireless only. So if I want the probability that exactly 5 are wireless only, there's a couple ways to do it. One way is I can come over here on my graph, and where I see 5, I can just click on that. And so this number here is the probability of exactly 5. And usually in probabilities, we like to keep 4 digits. So I would say it's 0.2023. I can also get that up here. And it's not really a cumulative probability, but if I just put a 5 here and a 5 here, so I select the inner region and I say go from 5 to 5, it does the same thing. And you'll see that it also highlights that. And it gives me that same probability. If I click this down arrow, it shows me all of the digits. So I again have 0.2023 if I round to 4 decimal places. So this would be the probability of exactly 5. And if I want exactly a number, I just put the same number on both sides, or I click on its point over here. Now, if I wanted a range of values, say I want the probability that the number of households in 20 that are wireless only is between 5 and 7, then I'm going to select inner, and I'm just going to select 5 as my lower bound and 7 as my upper bound. And you can see over here that it's including 5, 6, and 7. So it's going to calculate all of those, add them all up for you. And you can see we get a probability. If we want 4 decimal places, we have 0.4833. Now, what if I didn't want to include those endpoints 5 and 7? What if I wanted the probability that it was, say, between 3 and 9, not including 3 and 9? So between 3 and 9 and not including 3 and 9, well, I wouldn't include 3, I would start at 4. And I wouldn't include 9, I would stop at 8. So you can see this gives me values that are between 3, so not 3, but anything greater than 4 and less than 9. So that's all the values from 4 to 8. We can also just do something either a less than or a greater than. So if I wanted to do something like what's the probability that fewer than 3 of these 20 households are wireless only, then that would be a left probability, a less than. And notice if I want fewer than 3, I don't want to put 3 here because it's going to include 3. And 3 is not fewer than 3. So I want to put a 2 here. And that's going to give me the probability that it's 0, 1, or 2, which is the same as saying the probability that it's less than 3. And so that probability for 4 decimal places, I click on my down arrow and I have 0.0913 rounding to 4 decimal places. We could also do something like what's the probability that it's at least 3. So let's think about what at least 3 means. That's going to be a greater than, so I want a right-sided probability. But I don't want to start at 2. Do I want to start at 3? Well, 3 is at least 3, yes. So I'm going to include 3. And I have a probability of 0.9088. And that's the end of what we have for today. So play around with it. And if you need additional help, please ask questions.